Thank you for coming for the presentation today. So we are going to discuss like a very less talked about topics, but very important topic that can be leveraged through LLMs in today's world. So cybersecurity has been like a very tedious domain, and it has been evolving with a very high speed. And for us, it becomes like eventually very difficult to keep track of each and every thing that is coming up and how to leverage certain information corresponding to it and how to understand those technical terms to say. This is the place where LLM actually can be very helpful because it has access to all the internet stuff. It knows what the domain looks like, what the authentication steps are. So it has like majority of the knowledge and what corresponds to or what kind of attacks can happen in real-time world. Apart from this, I'll take like very simple example to illustrate why this is like kind of important, not only for enterprises to be up to date with cyber information, but also for people like us who want to be safe in our day-to-day life as well. So we receive like on monthly basis thousands of emails. Now, whenever we open any kind of email, there is always or 50% chances that it might contain like certain links attached to it. That link might seem kind of legitimate, but what happens at the end of the day, we actually don't know, because there are a lot of tactics that they can use, SQL injections, or maybe using like certain specific other language words to replace the alphabets in the URL as well. Now, because of these all tedious, sneakiness into how these URLs are actually created, it is a kind of a hurdle for us, and we, end up becoming the victims of the phishing scams. So how it will work is like we'll receive like some sort of email attached to it. There'll be a link, and that link will take us to some, let's say, company domain, and it asks for our credentials and shows some urgency attached to it. Now, once that is done, we provide our credentials to that particular domain. Now, once the threat actor or any attacker has access to that particular password, just because for the sake of simplicity, we keep the password same for majority of our banking activities or maybe some phone authentications, it is very easy to convert that into a spray attack. So they can use the same password to log into your bank accounts or any other account per se. So this illustration will be very centric to a use case where we can step up and take a step and take a move in order to at least know something about what domains or what website we are visiting at the end of the day. Now, the motivation behind this entire project or the demo is that we can leverage all the information which is available on the website and try to make sense out of it using an LLM. Now, I'm going to start with a very small example, which is very specific to the domain or the IP addresses. So we'll take one domain and try to see what all information is available on the internet. Okay. Now, this is very big information even when it comes to a very small specific indicator, which is domain name. Now, over the time, there are like thousands of domains that are registered. Some domains are registered just for the malware practices or sending the phishing scams to the users. Now, static-based rules are very confined in a way that they are designed by us, so they represent our knowledge on that topic only. So they might not be able to do justice with evolving threats, landscape, and maybe some tactics which are coming up new. There are certain kind of false positives. So for example, let's say I am trying to test some application and I have my personal domain, which is created nowadays, or the company domain, then it becomes essential that the LLM doesn't know about it. It just sees certain parameters. But if I have some certain kind of feedback and I can pinpoint which is false positive, which is false negative, this kind of feedback can help LLM actually iterate over it and maybe provide like more information and cater to that particular need and train the model or make those feedback into consideration as well. Now, as we discussed, like a few points why agentic AI could be helpful, specifically the LLM part of it as well. It provides like automation. Like it doesn't have to be, the sequential thing that you have to do this, and that first, but it can integrate the intelligence part at the back end and then gives us the result that we were actually not expecting. These kind of things can actually help us in the coherent analysis as well. It can capture diverse signals and take decisions which information to use at the end of the day and how to leverage, for example, from the domain. There might be certain scenarios where we are able to get or extract IP addresses attached to it and then use that IP address to leverage more information too. And again, the continuous feedback which can be leveraged to LLM as well. I am going to start with the model components that we are later going to integrate into an architecture, and then we'll go to a very small demo as well to understand how it will work at the end of the day. First of all, like let's say, as we are starting with the domain itself, we have certain data collection tools. I have picked a few, and the ones that I have picked are just for the demo purposes. And I also wanted to highlight this part that they are not actually endorsed by Microsoft or anyone. So first of the domain or the data collection tool is WHOIS. So it is, you can access it or download the local DB as well, or for the freshness of the data, you can use the API too. This is a very particular domain generally used for the illustration purposes, example.com. And as you can see, we only had the name of the domain itself. However, this WHOIS database is able to convert or get the IP address out of it as well. Now, what is WHOIS? It actually helps individuals or companies to register domains, and it has like certain information related to what registrar or who is the one who's registering this particular domain with them. That is important because it could be the case that certain registrars are suspicious. So you have observed certain activities from certain registrars. Now you want to highlight that. This is like kind of information which can be really helpful. Apart from this, it actually gives you like what was the last date when it was actually created. So creation date can also again play an important role in identifying whether this particular domain is malicious or not, because whenever the domain is relatively new and you have never seen it, it means that it was created specifically to send out the email to you or maybe for other malicious activities as well. I'll show like another example where it gives like more information than this as well. So it gives like other IP addresses that might be associated with this domain. Then other similar domains that might not be that useful though, but the data looks like this. This is the format of the data. What was the registration date, expiration date, when was it last changed, and certain links attached to it as well. Let's look at the uptime related to it. It gives like more information on when this particular domain was actually active, when it was not actually active. So this kind of time series analysis could also be again informative in a way that if the domain was inactive for the period when before you received an email, but now it is somehow active and then inactive again it says something about the pattern which goes behind it. The next data source is GeoIP. Again, it is available to download locally as well as we have the API to refresh the data, but this is what the output of this particular call looks like. It will give you the information on the country of the IP address or the domain itself, the country code, what is region, longitude, latitude, what the time zone is. Why is this particular information relevant is that you can pinpoint or filter certain countries as well or certain regions as well depending upon how you perceive or maybe related to certain threat intel reports as well that are public. So based on those information, there could be blacklist or whitelisting of these IPs too. So, yeah. The third and the last source that I'm using for this demo purpose is VirusTotal. It gives like more information around the domain in terms of the threat feeds. What do we mean by threat feeds is that there will be certain information, certain engines which is running on this domain, and it will give you some information how many those analyzers have flagged this domain to be suspicious. So to give a broader view of this, there is like a community score, which is like 0 out of 94. So it means that out of 94 scans that have been run, or the providers that are running these scans, 0 have been able to find it to be anything near to being malicious. Community score is something that somebody has seen this domain, they can upvote or downvote, kind of a crowdsourcing intelligence there. There is like, again, creation date, which is like 30 years ago, last analysis day, 14 hours. And corresponding to it, you will be able to get like the different categories, what category this particular domain belongs to. And there are certain calls that they do, like pings as well, to check whether this domain is active or it is not active, and provide like more information attached to it. Now, these were the data sources that I have used. Now, going back to the slides. For just the simple example, how should we go about, since we have like all this information, but how do we leverage this information in terms of creating a static scale as well as using LLM intelligence in order to enrich it further? We'll talk about like two types of features as of now, which one is deterministic one, and another one is a flexible feature, which is like contributed by LLM. This deterministic feature can range between 0 to 10 based on whatever information we are able to get out of it. And for the demo purpose, I'm using domain age that we encounter at various places in the data source. We are going to use country to filter out any whitelist or blacklist, any kind of countries there, and the threat hits that we were able to see on the VirusTotal. Now, these information can be actually weighted as well, because let's say country, we don't want to give like more weightage to the country part of the domain. We can give like less weightage or assign the weightage according to the importance of the feature as well. In this particular example, the LLM is asked to take into consideration the data which is provided and instructed to actually look into other frameworks as well to categorize and understand it better. It has like text data, as we're talking about, that goes to LLM itself, and then it shows some sort of a verdict or some explanation why it thinks it is malicious or non-malicious. Apart from this, these deterministic features are also added to LLM to provide like more information around the fact that if these are the information that we want to leverage, the LLM doesn't discard these information too. Looking at the, because this entire infrastructure is going to be like one short thing, and you can make it conversational and put the memory to be the shared memory as well. However, let's say there are other users or other people who are also want to query your engine, then it is worthwhile to check and look at the memory and the feedback tool, or create or store it somewhere as well. For the memory access tool, there are certain scenarios where you want to look at what were the last domains or IPs that I actually looked at and how they are compared to the current IP that I'm trying to investigate. For feedback ingestion, again, the whitelisting of certain IPs, then you want another feature to be given like more importance. You can add those information over here, and it will be auto-ingested into via another agent into the LLM itself. Now, let's look at like the basic architecture that I used in this. So I prepared like a Streamlit app where user can actually query. Once they query the app, they will go to the orchestrator agent For the entire infra building, I'm using LangChain. Now, these are the tools that are actually available to the agent, and it has to decide between, like, if I'm giving IP address, which one to call first. If I'm giving it the domain name, which one to actually call first. So it has like who is data source available. It will call the API and then fetch the data corresponding to it. Then geo-IP data available as well. Then thread feed also available. And geo-IP is generally available for the IP addresses itself. It doesn't work on the domain. Then it has like a store target tool. And at the end of the day, there's an explanation with certain instructions on how to analyze that data as well. Once the user actually, or the agent is able to get the answer out of it, it is provided to the user as well, and it is fed back to the memory database too. Now, once the user has some sort of information available with them, they can go ahead and provide their feedback, which is like formatted. They can say yes or no, or they can provide like detailed feedback that can be later used. For the purpose when there is like repeated question, or they want to see analysis across all the previous information or queries, they can go ahead and look at the memory DB as well. And this feedback is again ingested into the orchestrator agent. And we can use like Grafana to monitor actually the tool latencies and is there any compilation error corresponding to it or not. I'll just move to the demo part now. Since it is hosted on Streamlit, I'm just gonna run that. Yeah, so this is what the interface looks like, very simple one. Now, I just want to ask, like, tell me what all you know about. Since once it is running, we can go ahead and look at what the calls looks like. Okay. Yeah. So since it is running, let's look at what the background processes look like. So it actually started and invoked fetch whois, which is like getting the data out of whois for example.com, and corresponding to it, it received like this kind of raw data. Then it actually ran it over the whois IP using the IP address corresponding to this example domain, and then it was able to receive like the information related to the geo IPs as well. Then the next step, it looked at or invoked the fetch target thread feed, and it looked at the YS total. Finally, it tried to compare or compute a particular score corresponding to it, and then get the explanation out of the LLM, and based on the entire information, it is able to give the output, which is corresponding to example.com, and looks like this. So it shows like information related to whois, which is when was it created, like, which seems to be like informative and for the scoring part as well, and who is the one that, or the authority that has actually registered it. Geo IP, again, it has provided like certain information on when it actually was created with the longitude and latitude. Thread feed, it shows like 0 malicious activity, no suspicions as well, and 29 detected harmless entries. Risk score is actually computed by the static function, and it gives like 1.7 based on all the rules that were actually put into it. Based on the information related to country. Explanation is after analyzing all the information that was fed into it, it says that based on every evidence, there is no malicious activity which was observed for this particular domain. So we can say, or for the feedback purposes, we can uptake it and maybe provide like some information over there. And this will be submitted, and this the entire exercise, or this all the information is actually put into feedback as well as the MemoryDB too. This is a very simple example how these things can be, or the LLM or Agentic AI can be used for leveraging or understanding the information related to cybersecurity. And this is like, there is only one example provided, a very straightforward call. However, there are certain DBs that talk about ransomware activities in the wild. They talk about CVEs that are associated with a particular OS. They also have certain information on how a CVE can be actually exploited and how you can prevent it. So all that information can again be used in order to understand how to better protect our systems as well as our activities too. A few considerations while we are building up these kind of applications. So to start with, like I showed a very basic example related to Streamlit app. However, for the production purposes, we can use REST API too, so that at the end of the day, if this particular information has to be ingested into a system for other predictions as well, it can be leveraged there too. CI/CD pipelines as well, unit testing using Agentic corresponding to it can also be leveraged. And build and release can be tracked over GitHub as well. Scaling opportunities are available. We can track the volume of the queries that we are receiving, or the latencies or the error rate as well, using Prometheus metrics. And we can alert as well using Grafana or any other alerting tool based on these metrics that we actually observe. It is always better to log and track all the user activity which are actually happening, so that whenever you go back to the logs, you can also provide like certain feedback and ingest those feedback as well. Very important part over here is like we do not provide any kind of credentials or PII data or sensitive data which might be important for other individuals as well, and they can't leverage it if we are putting it into feedback DB, and LLM also can't leverage it, to keep it separate as well. Data retention policies, again, like because after a certain point of time, these domains are going to be very dynamic, and these data are not supposed to be retained for a lot of long period of time. Same goes with the feedback as well, because LLM will be fetching that feedback to self-train it. API keys, again, they are supposed to be taken from the cloud walls, or maybe use the environmental variables if you're testing it locally too. OpenAI usage and cost monitoring. So there were like multiple tools. In the tools, the LLM was used, and for the orchestration purposes also LLM was used. For tools purposes, it is generally recommended, or OpenAI 4 model works like much better as compared to 3.5 turbo, whereas 3.5 turbo is like cheapest option available as of now. So for the explanation part, we can use like 3.5, and for tool selection part, we can use 4. And we can optimize these and control the cost corresponding to it in a manner that each and every tool or every LLM call that we make is optimized according to the use case as well as the corresponding version of GPT which is available. RBAC is like another important factor when you are scaling it on in terms of the enterprise as well, because certain domains might not be accessible to certain group of individuals. However, other group of individuals are adding like more feedback to it, which is not to be accessed. So raw level or maybe column level RBAC can be installed or applied to the entire database too. Yeah. If you want to download the slides or want to give it a try to the code as well, just go ahead, and it is available openly on GitHub. You can scan this code and try to see, or maybe even test that out. There are other functionalities. So there are individuals who actually download the firewall rules, and once they have downloaded the firewall rules, LLM is actually put into analysis of that, and if LLM sees any kind of blockage or any kind of malfunction into it, they are sandboxed, and the rules or controls are applied, and those firewalls are actually reconfigured but under sandbox. So this was a very simple example that we went ahead with, but the possibilities are like numerous. And agentic AI systems can actually configure your firewalls or any OSs as well. You can auto install the updates or versions, or keep it at a simple version of the OS as well. So the entire presentation was to give a very simple use case in the cyber domain and encourage to maybe leverage more in that direction. Yeah. If anybody has any question, please feel free to ask.